Good morning, geometry. Welcome back to our next section in quadrilaterals. Last time we talked about parallelograms. This time we're going to talk about rectangles, which actually is a subset of parallelograms. A rectangle is a type of parallelogram. Parallelograms have opposite sides that are parallel and equal. Rectangles have the same. So some properties that we're going to need to know about rectangles. This time I don't have my markers with me, but if you want to do these in the colors that are listed there, feel free. So feel free to pause the video, go grab some colors, and then come back. But anyway, in a rectangle, opposite sides are parallel, just like with parallelograms. Parallel. So we can mark the sides parallel. In a rectangle, the opposite sides are also congruent. Congruent. So you can mark them with the dash marks. So opposite sides congruent, opposite sides congruent. And in a rectangle, opposite angles are congruent as well. Opposite angles are congruent. In a rectangle, the consecutive angles are also congruent. They are they're also supplementary, congruent and supplementary. So I think in this one, when we jump down here to in a rectangle, all four angles are, well, congruent. So the supplementary, although those first four, parallel, congruent, congruent, and supplementary, those are the ones that it inherits from the parallelograms. We could say parallelogram is kind of the parent shape, and then rectangles is a child of the parallelogram. So it inherits those traits. Some traits that are unique to the rectangle are that all four angles are congruent, that the consecutive angles are congruent. Diagonals. From parallelograms, we know that the diagonals bisect each other. In a rectangle, diagonals bisect and are congruent. So congruent is new. Okay? The diagonals in parallelograms were not congruent. One was longer than the other one. But in a rectangle, the diagonals are congruent. So let's put some more markings on here. We had the opposite angles are congruent. I kind of was jumping around, and so I wanted to make sure that I was putting the right ones there. So all four angles are congruent and right. Congruent and all four angles are right angles. So we could put those, instead of congruence markings, we could put those as right angle markings. Okay, so put the little boxes in the corners instead of the congruence markings. There we go. Diagonals bisect and are congruent, so not only are those two congruent, but since the diagonals bisect each other and the diagonals are the same length, all four of those segments that meet in the middle are congruent. Kind of cool. So let's use those facts to find some missing measures here. So in this one, AB is 16. AB, 16. BC is 10. So we can find CD, the side opposite the 16, that's 16 as well. DA, side opposite the 10, opposite sides are congruent. So we could use those markings to help us out. So that's also 10. AC is 18. AC, that diagonal, is 18, and the diagonals bisect each other. So if this is 18, then each of those halves are 9. And since the diagonals are congruent as well, then these ones are also going to be 9. So BD, the other diagonal, also 18. AE, 9. BE, also 9. CE, also 9. And DE, also 9. The angles in a right triangle, angles in a rectangle are right. So if all these angles are right angles, if we know that ABE E is 36 degrees, well, this being a right angle, we'll be able to find its complement here in 54 degrees, right? 90 minus 36 is 54. So when we find CDE, CDE, that's this angle down here. It's the alternate interior angle to that one up there. So that's also 36. AEB, AEB, this middle angle here, well, if that's 36 and these are congruent, then the base angles on that triangle are congruent. This is also 36 degrees. And so we could use the triangle sum theorem to say, well, if that's 36 and that's 36, we could add those together and then take that away from 180. 180 minus 72 gets us 108. So this is 108 degrees in here. Okay, so 36 and 36 put together are 72. Subtract from 108 to find that middle angle there, 108. EBC, EBC, this angle here, 54, we already found that. So sometimes when you're solving things, if something occurs to you, go ahead and try to find that missing angle, even if it's not something we've been asked yet, because it might come in handy later. Angle EDA, EDA, this would be the complement to the 36 there, so 54 there as well. So what's nice about these is we don't really, since we have so much information about rectangles, if we know that it's a rectangle, we don't really have to use the supplementary piece here for consecutive. We can use the fact that this is a right angle corner and the fact that the alternate interior angles are congruent to find lots of missing measures. BEC, BEC is this angle here. We could use the fact that these are both 54 and take that away from 180, or this 108 here is already a linear pair with that one, so we could subtract that from 180 to get this is 72. And that actually should look familiar, that's 72 degrees, because it's the sum of the 36 degree angles here. And 72, if we think way back to our section on angle pairs or on triangles, an exterior angle on a triangle is the sum of the two non-adjacent interior angles. So 72 being the exterior partner to this 108 is those 36s put together. So you could take that as a little shortcut as well if you want. Angle BCE, BCE, we already have that filled in as 54 degrees. DAE, DAE, that's also going to be 54. CED, CED, that's the vertical pair to that 108 there, so 108 as well. ECD, ECD, also 36 down here. EAB, EAB, 36 as well. And DEA, DEA, that one's the vertical pair to that 72 there, so 72 degrees. Okay, so all the angles that we can find, once we've found one of them, all we knew here was that 36 degree angle. We were able to find all of the rest. So pretty powerful stuff. If we know that this is a rectangle, just knowing that those are right angle corners and the opposite sides are the same, that gives us an awful lot of information. Let's take a look at another couple examples, and then we'll wrap up our rectangles section here before moving on to another special type of parallelogram. So here we got our rectangles. We have this example rectangle here, A, B, C, D, with some angles 1, 2, 3, 4, 5, and 6. And it says if AC is 32, so AC being that diagonal. So if we have a rectangle, we have AC is 32. What is AE? The AE, here's C. AE is just half of that. So AE is 32 divided by 2, so 16. Okay, the two halves, AC is the length of the diagonals bisect each other in a rectangle, so the two halves are both just half of the 32. So AE 16. Measure of angle 2 is 41. So in our rectangle here, angle 2 is this angle here. If you look up there, there's angle 2. Is 41 degrees. What is the measure of angle 6? Angle 6 is this one over here. Those are alternate interior angles, so that's also 41 degrees. Okay, angle 2 and angle 6 are the same size. Let's look at just these two here, and then we'll do 5 and 6 in class. 3 is, the measure of angle 5 is x. So if I measure of angle 5 is x. Measure of angle 6 is this one here, 2x minus 30. In a rectangle, the two angles in the corner are complementary. Rectangles have right angle corners, so we're going to have 2x minus 30 plus x equals 90 degrees. 90 degrees in the corner there. So 2x plus x is 3x minus 30 equals 90. We can add 30 to get 120, and then divide to find that x is 40. Okay, so we found x. For this one, AC, AC is 15x. BD is the other diagonal, is 3x plus 144. So notice AC is one diagonal, BD is the other diagonal. In a rectangle, the diagonals are equal. That isn't true in parallelograms in general, or for all parallelograms, just for rectangles. So AC and BD are equal to each other. We can say 15x equals 3x plus 144, and then solve. So we can subtract 3x to get 12x, and then divide by 12 to find x is 12. Okay, we'll take a look at those last two in class together. I'm going to stop the video here, and I'm going to make a separate video for rhombuses, but that's also part of Q2. So tune in for that next one. I'll talk to you in a bit.